Good morning, everyone. Welcome to this new webinar by the International Energy Agency. So today, my colleague Zakia and myself will be happy to do some wrap-up of all the topics we have discussed over the course of the past 3 weeks. And we are very sad to close this training, but very happy that we've been able to discuss all those interesting things over the past days. So today it will be more about some quiz, trying to bring some gaming into our way of working on energy statistics and energy modeling. And from 10, we will have a very quick closing of this online course, hopefully with a high representative from the Ministry of Energy of Zambia and also from IEA authorities. And we'll also have the executive director of SACRI who will share a word. And then we will present also to you the next steps under our collaboration, because this online course was just a first step. So just reminding you on where we are, this is the number 12 and last session. So wrapping up and closing, as we just mentioned, we are anticipating to end by 10:30, so earlier than the other days. So on today, Zakia and myself will present to you many questions on Menti. So Zakia, you will do it on statistics in the second half of the session.
Yeah.
And I will start right now with modeling. So it will be mostly using Menti. So we invite you to, as always, take your smartphone or open another window of your computer to jump on this. I will share my screen. Okay, so welcome to this quiz, and with the first part on modeling. So the code to use, and we will keep the same for all those questions, is on the top part of the screen. It's 71922284. And we will have a bit more than 10 questions on modeling that will enable us to rediscuss all the sessions we've worked on together. So I'm showing the first question, which, as you may remember, when we started discussing modeling, we started with socioeconomic drivers, and before being able to look at how energy demand will evolve in the future, we have been looking at how GDP is set to evolve, how population and demographics trends are to evolve. So here is the first question we are asking to you is, you have a figure with 3 different bars with growth of urban population. According to you, which bar represents the growth of urban population in Africa between the year 2018 and 2040? So we are looking at an increase of urban population by a bit less than 600 million people for the red bar, of 300 million people for the purple, and for less than 400 million people for the yellow bar. Which bar do you think is Africa for the coming 2 decades? Okay, so we are getting some results. Most of you think it's the red bar, some the yellow bar. So for you, African urban population is to grow by minimum, like let's say 350 million people, or more likely 600 million people. I give you a few more minutes or seconds. Okay, so the right answer is the red bar. Because, and as you can see on this figure, the other bars were for China and India, or the yellow bar was China urban population growth during the 2 decades of the great Chinese economic boom between 1990s and 2020s. The purple one is the urbanization we expect for India, and the red one is the one for Africa. So in other terms, this means that we expect something which is almost the double as what China experienced during its decades of economic boom, which had led to a sharp increase in energy demand, in GDP as well. So this would have very strong consequences for Africa. And on the right chart, you can see that we anticipate this urban population growth to come with an increase in demand for cement, for example, to build the cities or the houses for all those people who will grow in cities or move from rural areas to cities. Okay, so next question. Here you see 3 series of bars, which represent energy mix of primary energy demand of 3 different countries. So you have historical data, the year 2010 and 2018, and you have projection. And you can see the different fuels with the legend on the right part. The question is, according to you, which number is South Africa? And you have different hints. You can look at what the mix is today. Is there a strong share of bioenergy, like on number 1, or a strong share of coal, like on number 3? You can look at the future evolution. Do we expect this total primary energy demand to increase sharply or to remain stable? Okay, so you're mostly voting on number 3. I just wait for a few more answers. Okay, number 3 or number 2. I show you the answer, and it's number 3 indeed. And 2 good examples or reason for that can be the share of coal in today's energy mix for South Africa, and the fact that we don't expect total primary energy demand to increase sharply in South Africa because the economy is already at a developed level that we would not entail into more energy demand, even though we expect GDP to rise, and this cannot be seen very clearly, but these are the orange dots on the chart as well. You would have other countries, Ethiopia with today a strong share of bioenergy, or Angola, which is relying a lot on oil, being a strong hydrocarbon producer. Okay, now let's discuss scenario. As you remember, we don't know what the future will be made of, but what we can do is to develop scenario and make projections. We have often talked to you about the stated policies or steps scenario, which is what is set to happen under announced policies, under current trends, and other scenario like the Africa case, which we defined as including the goal of universal access to electricity and to clean cooking, which also takes an assumption of higher GDP and inclusive and sustainable economy as per the goal that the African countries took under the Africa Union 2063 agenda, and which also limits climate impacts and pollution. So these are the assumptions behind the Africa case. When you look at this chart, which is also the primary energy demand evolution, where do you think is the Africa case? Is it number 1 or is it number 2? Okay, we are getting a few answers for number 2. So again, one assumption under the Africa case is universal access to electricity, universal access to clean cooking. If you think all African having access to clean cooking means, what can that entail in terms of mix of fuels, in terms of primary energy demand? Okay, so most of you are voting for the number 2, and that's indeed the case. You can see with the orange dot that GDP is higher in this scenario. And when it comes to universal access, so with everyone having access to clean cooking, we expect a move away from traditional biomass. So this is why the light green bar is reduced as compared to the stated policies. We will have less people relying on charcoal or on wood stick for cooking, but instead we would have more people relying on LPG, which would mean a higher demand for oil. And we also expect to have more electricity demand, so a higher share for solar PV, for hydro, and other low carbon sources of electricity. And the key difference between those two scenarios is that the GDP in the Africa case is 60% higher than in the stated policy scenario, but with a lower energy demand. So this means that Africa has a possibility to power a stronger economy with less energy due to energy efficiency savings, due to people moving away from the traditional use of biomass and moving to more modern fuels for cooking, for instance. Okay, one more that will take maybe a bit more time to fill in, which is about the different fuels and sources of energies. So here you can see mixed evolution in various regions. So for example, on the left part in China, you would see between the year 2005 and the year 1990 how energy demand evolved by different fuel. And the question is that you are not given the legend today, and you are asked to identify which fuel is number 5 gray area, which fuel is number 3 red bar, etc. So you can see this for China over the past period. You can also see it for India over the past 2 decades. And you can see it for Africa for the coming 2 decades under our 2 scenario, so the steps and the Africa case. So you are just asked to associate the numbers with the right fuels. For example, which fuel could be oil, which number could be traditional biomass, etc. So maybe looking at Africa only, you can have in mind what we just said on the difference between Africa case and steps. You can see the green bar is increasing in the steps and is decreasing importantly in the Africa case. What source of energy would be reduced in the Africa case? So that's one hint. Likewise, you can see that in the Africa case, the light blue bar is rising much more than in the steps scenario. And then on the gray one, maybe you can think of one source of energy which has been very much developed in India and in China in the past. Okay, so being cautious of time, I will show the answer, and we will can comment that. So maybe you got that, but the green one was biomass, and as we said, we expect people to move away from biomass in the Africa case. Then the gray one was coal, and China and India have heavily relied on development of coal for power generation to power their socioeconomic development over the past decades. The then number 4 was oil, and we expect in our 2 scenario for Africa a rise in oil demand. Natural gas is also something that is also a source of power generation, but also an important source of energy for the industry as an entrant, for example, that is expected to grow in both our scenario for Africa. Light blue was renewables, and this would be really the winner under our Africa case, with a strong development of solar PV, but also of other sources of renewable. And the dark blue was nuclear, which also has some potential in the continent. So thank you for your answers. So now we are looking in the case of Ethiopia, but it's more understanding the trends. We are looking at still the differences between one scenario, which is the steps, and another, which is the Africa case. So you can see that we have fossil fuel final energy consumption and electricity final energy consumption in 2040 under those 2 scenarios. And the difference between steps and Africa case can be decomposed with some upward change, which is the purple bar, and some downward change, which is the blue bar. So according to you, what parameters can lead to an upward change, so a further increase in final energy consumption, as opposed to parameters that could lead to downward changes? And you are proposed some parameters like more energy efficiency, higher GDP, lower urbanization, or more people with access to energy. So the reasoning is, if we have more energy efficiency, would that entail an increase in energy demand? If we have higher GDP, would that entail an increase in energy demand? So I see that you are mostly rating higher GDP and more people with energy access. And these are indeed the good answers. Because when we look at this figure with the right legend, we can see that higher GDP would entail more demand for different sources of energies, both fossil fuels and electricity. Higher access would also entail higher needs for example, electricity for cooking or electricity just for universal access to electricity. On the contrary, efficiency is something that would drive downwards the final energy consumption. So energy efficiency is a very strong way to limit the growth of energy demand in the future, and we can have energy efficiency all across the energy sectors. Energy efficiency is a source of energy that all countries have at their disposal. Okay, so again, discussing different ways of limiting the future growth of energy demand, taking the example of oil. If we think of the transport sector, So what parameters do you think policies could influence in order to limit the growth of oil demand? And you are proposed the passenger kilometer, efficiency of cars, number of passengers per car, and average age of car fleet. Okay, so you're mostly voting for efficiency of cars. Indeed, this is a key parameter policies can influence. This can go through the average age of car fleet because policymakers can have different levers. They can prevent all cars from being used in the roads. So, and this would have a consequence on the average efficiency of the car fleet. Then number of passengers per car is something more difficult for policies to influence, even though in, for example, in OECD countries, we can see some strong policies for car sharing to make sure that we have less cars on the roads because we have more people in each car. And passenger kilometer, as you may remember, and I'm putting it here, passenger kilometer will be the aggregated variable to reflect the intensity of the transport of passengers. So we multiply the number of vehicles by the distance traveled by each vehicle and by the occupation of each. Okay, trying to accelerate. Now looking at the residential sector. So if we want to estimate future energy demand for cooling, what would be the best activity variable to look at? And you have other examples. For example, if we want to know what will be the energy demand in the future for cooking, we will start looking at people per household. This is the best activity variable. In the case of cooling services, what would be the best variable? So another example for water heating, what we look at is the number of people per household, because regardless of the size of your apartment, the main driver of consumption or demand for hot water is how many people you have, because how many shower people will take, or etc. Okay, so we have quite diverse answers. There are different activity variables that can help, but if we had to take only one, it would be the ownership rate of AC units. So how many air conditioner we have per household, but maybe we don't have this directly. And another interesting variable would be the floor space per household, because we would understand how much space needs to be cooled. So those two answers could be right. Now, the next question is, if we take the ownership rate of AC units per household as activity variable, but we don't know how this will evolve in the future. If we want to, you may remember, to take a proxy, so trying to see how another variable will evolve and find a function between this ownership rate of AC units and income, so GNI per capita, what type of curve do you think, or what type of relation we would get between ownership rate and income or GNI per capita? Okay, so to you it's mostly an S curve. Um, let's look a bit at what we discussed on that. So this is an S curve where we can see refrigerator ownership on the left part as a function of an aggregated criterion, which includes income, urbanization, and electrification. So you may remember then that when there is very low income or urbanization, the number of household of a refrigerator per household is low. As income is rising, people are acquiring some equipment, but then even if you continue having higher income, people will not have multiple refrigerator. So this is the sense of the S curve. You may also remember that to identify S curves, we sometimes need more than income information. Here it was about cooling. And if we don't include the color information with what's the temperature in this country, it's not easy to identify S curves. And last, we can see again this type of S curves with the number of refrigerators or AC units per household based on income and other information. So the right answer was S curve indeed. Okay, let's move to the power sector very, very quickly. Again, it's a question about different electricity mix in the continent. You have 3 countries. You are asked to find which one is Ethiopia. Maybe you're not very familiar with Ethiopia electricity mix. I can tell you that it's somehow similar to the one in Zambia. Okay, so mostly you're voting for number 2 with a very high share of hydro. And this is indeed the case. And we expect Ethiopia to develop further its hydro capacity as well as solar PV. Kenya is a very diverse energy mix with a strong share of geothermal, but also hydro, solar PV, and others. And in Cote d'Ivoire, there is a lot of gas related to the local and domestic available resources. Okay, maybe you remember for the electricity annual hourly demand. Oh, sorry, I will pass this one. Just showing you that we can look at electricity demand at an annual curve, then monthly and then daily, and we can see some patterns with sometimes countries with higher electricity demand in winter because it's a warm country where there is need for cooling, or as you can see here, a higher electricity demand in in winter because it's cold and they need some space heating. If you look at monthly curves, you would see working days and weekends with lower demand during the weekend. And if you look for the day, you would see also some pattern of consumption with a peak at the evening time. So now here you can see some projections of electricity demand, considering that the red curve is the total electricity demand. What shall be the total installed capacity? Would that be the yellow line or the blue line, given that between the red and the yellow, you have to use the peak to average ratio? Okay, you're mostly, no, it's half. So I show you the answer and explain again. So once you have electricity demand historical and projected in the future, you will use the peak to average ratio to ensure that you can supply always demand also at peak time, which means that your peak to average your peak can be 50% above the average, and you need your system to be able to supply for this peak time. But then you have another information, which is capacity margin or reserve capacity that is additional and brings you to the blue line in order to know your installed capacity. And this margin is due to sometimes maintenance or if what happens if some of your power plant is not operating, etc. So you need first to include the peak to average ratio and then to add a security capacity margin to be always able to match demand with your installed capacity of power. Coming to oil and gas, and I think this is one of the last slides. Again, we are looking at downward trends in terms of emissions of the oil and gas sector. So we all know that the oil and gas industry is very much emitting industry, and we need to address this challenge to be aligned with our goals of reducing greenhouse gases emissions. There is one parameter that can very heavily contribute to a drop in future emissions, which is the blue bar. According to you, what is it? And we're proposing, is it reducing flaring of CO2? Is it tackling methane? Is it reducing venting? Or is it the CO2 emissions from the own use of the oil and gas operations? So all the parameters we mentioned would contribute to reduce the emissions for oil and gas operations, but there is one, which is the blue one, who is really very much contributing to limiting those emissions. Okay, so to you is mostly the emissions from the own energy use. So I'm showing you the answer. No one is voting for methane, and methane is the right answer. You will see that in the case of oil, it's more than half of the drop in emissions. In the case of natural gas, it's 90%. And then you have energy-related CO2 emissions, which for oil operations are important, but not as much as methane. Flaring and venting all CO2 is also is already an area where oil and gas industries have put a lot of effort to reduce their emissions. Further efforts can be brought, but again, methane is really the low-hanging fruit and the highest contributor to emissions intensity decrease. Okay, I'm stopping here with this part of questions regarding modeling, projections, and giving you the floor, Zakia, to move back to statistics and balances.
Thanks, Arnaud. I will share my screen now. Can you stop sharing yours so that I could? Yeah. Can you see now my screen? Yeah. So welcome to this second part of the quiz, which is on statistics and balances. And the first question is, what do we include in national energy statistics and balances? Do we include the amounts of natural gas used for heating, solar energy reaching the earth, methane emitted while mining, coal, which is fugitive, fuel wood burn for cooking, electricity used while traveling abroad, or the natural gas used as ammonia feedstock? So here you can answer multiple answers. There are several good answers. So what do we include in national energy statistics and balances? Think about the different boundaries for energy, for reporting energy statistics based on the international recommendation of energy statistics, the IRS recommendations. So we have several answers arriving. And the correct answer is indeed the natural gas used for heating, fuel wood burn for cooking, and natural gas used as ammonia feedstock. We do not include the amount of solar energy reaching the earth. Methane emitted while mining coal, which is fugitive, is not included within the national energy statistics and balances, and also the amount of electricity used while traveling abroad. So this is not within your national energy statistics, but will be reported in the countries where you're traveling energy balance. And indeed, here it's very important that when you report energy statistics and balances, that you keep in mind a few concepts based on the international recommendation of energy statistics, where you have information on what energy products to report, which is based on the SIEC classification, which energy flows to report based on the ISIC classification. For production, you have to know exactly what to report under it, and for example, for natural gas, it's only the marketable production. For energy sector, also you have to take into account what to report under transformation, etc. There's also the reference territory to take into account what is your national territory, etc. Next question. So what is an example of how wood is used in energy statistics? So how do we report wood in energy statistics? Would you report material for making furniture, wood for burning for home heating, wood residues burned in a landfill, or none of these? So what would you report in energy statistics for wood? So many of you are reporting burning for home heating. Give you a few more seconds. And the correct answer is indeed burning for home heating. So for solid biofuels, we report only the amounts specifically used for energy purposes, and this is really only a very small amount of the total. So only wood that is used for energy purposes are included in energy statistics, and wood used to make furniture, etc., these are not reported. Next question. So which renewable energy source do you think takes the largest portion of global electricity production? So at the world level, which renewable energy source has the largest share for electricity production? Is it hydro, solid biofuels, or solar PV? Out of these three, which one accounts for the largest share in electricity production at the global level? So all of you are answering hydro. Let's see. So today, which of these renewable source accounts for the largest portion of global electricity production? And the right answer is indeed hydro. So in 2018, hydro accounted for nearly 16% of global electricity production, and non-hydro renewable sources accounted for a bit less than 10%. So hydro is the largest one. Next question, what is the largest energy consuming sector in the world? So which sector consumes the most in the world? Is it the residential sector, transport sector, industry sector? You can have two right answers. Think about at the world level, which sector consumes the most? So here it's shared between industry, residential, transport. Quite mixed answers. Many people think that it's residential, but most of you think it's industry. And the right answer is transport and industry. So at the world level, both industry and transport in 2019 accounted for 29% of the total final consumption, and residential sector was only 21% at the world level. Now, if we look at Africa, what is the largest energy consuming sector? Before we look at the world level, now at Africa level, which sector consumes the most? Is it residential, transport, or industry? So which sector consumes the most fuel? So many of you still think it's industry. A few of you think it's residential, and only 2 has replied transport. And here the right answer is residential. So contrary to the world, in Africa, the residential sector accounts for more than 50% of the total final consumption, followed by transport 20% and industry only 16%. But the residential sector, it's 54% in 2019. Next question, which of these regions have the highest share of renewable energy? And here when we say renewable, we also include traditional use of biomass in their total energy supply. So which of these regions, Asia, Latin America, or Africa, has the highest share of renewable energy in their total energy supply? Here we are not thinking of modern renewable energy. We are also including traditional use of biomass, so it englobes everything. So which of these regions has the highest share of renewable energy in their total energy supply? So it's mixed answers between Asia and Africa. And the correct answer is Africa. And in 2018, Africa accounted for 47% of the share of renewable in their total energy supply was 47%. And out of this 47%, 46 was solid biofuels. So this is an extract of Nigeria energy balance. And here we are asking you to look at the energy balance and tell us if the country is an energy producer, and if yes, of what products. So here, this is an extract of the energy balance, and analyze it and let us know if the country is an energy producer, and if so, of what products. So write down the products if you think it's yes or no, and if it is yes, which products is Nigeria producing? So this is an open-ended question. You have to write down the answer. Look at carefully this extract. Look at the different rows where you can find information on what is being produced in the country. So here, think maybe about what we said during the training on energy balances. Where is primary production reported? Where is secondary production reported? And list down all the answers. We have some answers arriving. So some us have said it's producing biofuels, crude oil. It produces crude oil, export greater than imports, crude oil, natural gas, hydro, biofuels. So here, I let you see again the table, look at the different products, primary, secondary, what is it producing? So yes, oil, biofuels, natural gas, crude oil, natural gas, yes, crude oil, coal, So here, when we look again at the table, we see that Nigeria produces a bit of coal, some crude oil, indeed, and most of it is exported. It produces some natural gas, hydro, a bit of geothermal, solar, etc., a lot of biofuels and waste. So these are primary production. Now, if we look at secondary production, this happens in the transformation sector below here, where positive numbers represent an output. So for example, here it's producing some oil products here. It's also producing some electricity, and it also has some liquefaction happening here, some crude oil produced from liquefaction. Next question. So looking again at, this is another extract, but we are focusing here on the Nigeria total final consumption sectors. And here, what is the largest final consumption sector? So you have information on industry, transport, other sector, non-energy use. And here we are asking you, what is the largest final consumption sector? So write it down like you did before. So in total, what is the largest final consumption sector for Nigeria in 2017? We see we have some answers arriving. So some think that it's the industry, 2 replied transport, 2 replied other. I'll just give you some more time to study the balance. So what is the largest final consumption sector here? And the correct answer is it's other, because if we go back to the image here, if you look at the total column here, you see that industry consumes 7,000 something KTOE, transport consumes 17,400, and other sector consume 106,400. And in other sector, it's the residential sector that's consuming the most energy in Nigeria. So next question. So here, what is the difference between a negative number and a positive number in the transformation sector? So here, the transformation sector, it's the highlighted, it's the red block. And here, what does it mean, a negative and a positive number here? Again, this was mentioned in the balances session. I also mentioned it a bit in the previous question. What is the significance of the sign, negative and positive sign, in the transformation sector? So write it down. Give you some time to think. So positive, it's the input, negative, it's the output, losses. So I let you look at the table. So maybe take the row of oil refineries. You have some negative number in crude oil. You have some positive number for oil products. And in the total, you have some negative values. So what does all these signs mean for the values? Look at electricity plants as well. You have some negative numbers for natural gas, hydro, geothermal, and under electricity, you have some positive values, and in total, you have some negative values. So let me see what, so negative signs are transformation in energy, losses, negative sign, negative losses, positive gains, input and output. Negative, it's an input. So indeed, many of you got it right. So if we take the example of oil refineries, the negative number for crude oil, it's the input of crude oil in refineries. So a negative number in transformation sector, here it's the input, and the output of the transformation, which is here oil products, it's a positive number. And in the total column, which is the sum of the rows, there the negative number represents the losses of the transformation sector. Same for electricity plants, you have the losses in the total, and the electricity output is a positive number, and all the fuels that go into the electricity production, so natural gas, hydro, geothermal, they are represented with a negative sign. Next question. Here you have to guess the country energy balance. So you don't know the country, you have just an extract of the energy balance, and you have to guess the country. And you have three possible possibilities. Is it Algeria, Ethiopia, or France? So you have three possibilities. Is it Algeria, Ethiopia, or France? I'll let you take some time to study the extract of the balance and think, can it be Algeria? Can it be France? Or can it be Ethiopia? Maybe think a bit about those countries. What could be the main fuel there, the fuel mix? What is their specificities? And try to see what could be the right answer. So we have a few people thinking that it's Algeria. One says Ethiopia. Now two, it's between Algeria and Ethiopia. I let you take some time again. So let me see, we have 10 people who replied. Most of you think it's Ethiopia, 4 thinks that it is Algeria. And the right answer it's Ethiopia. And this is because in Ethiopia, most of the electricity produced, it's from hydro. And you can see well here that in this balance, most of the electricity production, it's from hydro. There's also a big biofuels production here. Why is it not Algeria? What do we know about Algeria? Algeria is one of the biggest oil and natural gas producer and exporter. And here you can see very well that there's no oil and gas production, there's no oil and gas exports. And France, why is it not France? If you think about France, it is one of the biggest nuclear producer in the world. It's the second one producing electricity from nuclear. Nuclear accounts for 70% of France electricity mix, and it cannot also be France because here you have a big share of biofuels and waste. Next question. Africa accounts for what share of the global CO2 emissions? Is it less than 5%, between 5 and 10%, more than 10%? So what do you think is the share of Africa in the global CO2 emissions? Give you a few more seconds to think about it. During the CO2 emissions presentation, we had discussed this. There was a slide on this. So most of you now think that it's less than 5%. And the correct answer is indeed less than 5%. So today, in 2018, Africa accounted for less than 4% of the total CO2 emissions, of global CO2 emissions. Next question. What percentage of global CO2 emissions from fuel combustion in 2018 comes from coal? So what's the share of coal in global CO2 emissions? Is it 35%, 45%, or 55%? It's a bit hard, this one. So between coal, oil, and natural gas, what is the share of coal in global CO2 emissions? Many think that it's over 50%. And the right answer is 45%. In 2018, coal accounted for 44% of total CO2 emissions at the world level. So this is the last question. So countries representing approximately what percentage of the global CO2 emissions from fuel combustion have already pledged net zero emissions? So what is the share of countries that have already pledged net zero emissions? Is it 25%, around 50%, or 75%? And many think that it's only 25% of countries represent. So countries representing approximately what percentage of the global CO2 emissions from fuel combustion have already pledged net zero emissions? So the right answer here is around 50%. And if we look at the regional share of CO2 emissions from fuel combustion, we have yes, we have around 50% of countries have a pledge for net zero emissions target. Here we are excluding US, but if we include US, it's even more. It's around 65%. So this is the end of the quiz. I hope that you have enjoyed it, and I'll give the floor back to Arnaud.
Thank you very much, Zakia, and indeed, I hope everyone enjoyed the quiz, both on modeling and on energy statistics. So now it's time to close our online course, and we are very lucky to have with us the Honorable Minister, Mr. Matthew Nkua from the Ministry of Energy. We'll just check that everyone can correctly connect and maybe share the video. We also have the Executive Director of SACRI with us, as well as Rebecca Gagan from the International Energy Agency. So I hope that everyone is so. Kuda, Rebecca, are you able to activate your camera?
Yes, thank you. Good morning.
Morning.
Good morning. Thank you very much for joining us for this this closing time. And I think we also have Mr. Alan Chivunda, who is connecting for the Honorable Minister. Good morning, Excellency.
Good morning. Thank you. Good morning, team.
Good morning. Thank you very much for joining us. We are very honored of you being able to come with us and sharing a few closing remarks with our group of participants to this IEA training.
Thank you. Thank you so much.
So I understand, Excellency, that you are very short on time. So maybe we can give you the floor now for giving your closing remarks.
Yes, I can do it right away. Thank you very much. Mrs. Rebecca Gajehen, Director of the Division of Europe, Middle East, Africa and Latin America at the Office of the Global Energy Relations, Mr. Kuda Dukula, Executive Director, Southern Africa Center for Renewable Energy and Energy Efficiency, SACRI, Mr. Claude Bachgaupri, Head of Infrastructure, European Union Delegation to Zambia, senior government officials, representative of government institutions and agencies, ladies and gentlemen, I'm pleased to be with you today and to close this online course on energy statistics and modeling organization by International Energy Agency for Energy Professionals in Zambia. As we all know, energy is a critical enabler of sustainable development. Therefore, reliable, robust, and timely data is vital to the design and implementation of energy policies. It enables us to understand and to track our progress in our efforts to attain national development goals. Further, modeling and planning tools allow us to stimulate what the energy systems could look like in the future and therefore guide us in the formulation of long-term plans and our vision for the future. Ladies and gentlemen, the International Energy Agency expressed its interest to support Zambia in reinforcing capacities on both energy statistics and energy modeling, and today we all have been successful as of today. We've been the successful delivery on the first segment of this program. I'm informed that this program will contribute to the following: 1, enhancement capacity to energy statistics and the use of evidence-based analysis for long-term energy planning by means of integrated modeling tools. 2, development of evidence-based and data-driven policies on clean energy, energy access, energy affordability, and climate resilient strategies, as well as evidence-based investment decisions. And 3, development of more accurate and timely statistics and enriching the use of update of energy models for planning purposes. Ladies and gentlemen, over the past 3 weeks, a group of Zambian energy professionals have attended 25 hours of webinars with participants from the Ministry of Energy, Rural Electrification Authority, Energy Regulation Board, ZESCO, as well as from Ministry of Lands and Natural Resources, Ministry of Higher Education, and Ministry of National Development Planning. It is my hope that the participants in this training workshop have acquired the knowledge required to develop reliable energy statistics and to analyze and model energy demand. I urge you all to use this knowledge to enhance national energy planning for sustainable development. I'm aware that this online training was the first step within the program proposed by the IEA, and more training. Zambia is also very pleased to see that the IEA enforcing its ties with Africa, especially now that the continent's demand for sustainable energy services is increasing sharply. We welcome this initiative and commend the International Energy Agency for boosting the expertise of energy professionals in Zambia in energy statistics and modeling. We are also grateful to the European Union for funding this program. Ladies and gentlemen, I thank you and may God bless you all.
Thank you very much, Excellency. Rebecca would like to answer on behalf of the International Energy Agency.
Thank you very much. Honorable Minister, Honorable Executive Director, distinguished colleagues, ladies and gentlemen, good morning. On behalf of the IEA, I'm delighted to join you today. And I'd like to start because we have a number of thank yous. First, Honorable Minister, we were delighted you could join us and for placing such importance on reinforcing capacities on statistics and the use of modeling tools for long-term energy planning and policy making. We see this as essential for understanding what is happening in the energy markets and for making good policies. And so we're delighted to work with you and your team there. Second, speaking of your team, they have been extremely helpful in helping us organize this course. We are grateful to them and we work together very efficiently. And last but not least, all of the participants I want to thank for their interest in the course and their attention during the past 3 weeks. We know this has been a lot of time, 24 hours over 12 webinars. And I think one of our greatest regrets is we can't be there in Lusaka, because virtually this isn't as much fun, but we also don't get to meet you in person. We look forward to that opportunity. We also appreciate all of the feedback we've been given and the perspectives from Zambia's context. This helps us at the IEA understand better the dynamics, not only in Zambia, but across Southern Africa. And as you mentioned, sir, this is a big priority for us because we see such energy and dynamism across Africa. We've been working with countries around the world, and we're delighted to have the opportunity to share some of our experience with Africa, but also to learn from yours. We also have been pleased that we've had more than 35 energy experts participating in this course, watching the video recordings of the sessions. We hope that this material can continue to be of use for the energy professionals, not only those who participated, but for others. So please feel free to share this material, watch it again, look at the exercises, and please keep in touch with all of us, our team. We're here to give greater detail and to follow up with you. We've also tried to focus as much as possible on Zambia, the context of the SADC region, and we'd like to deepen this knowledge because it's a very important region. This initiative is meant to create dialogue and to bring to you what the IEA observes not only at the global level and in other regions, but also, as I said before, to understand the latest trends, data, and dynamics in Zambia and across SADC. In short, we see this as a win-win for everyone. So this was just the first step in our training program. And as soon as the situation will allow it, we will be delighted to, as I said, come to Lusaka, continue these training sessions, have more discussions, more dialogue, not only on statistics and modeling, but across the energy sector. So as I said at the opening, we see this as a first step in building a closer working relationship with all of you. And Mr. Minister, we hope that you'll be able to join us at our 3rd African Union Commission IEA Ministerial Forum in November, the 18th of November. So please put it on your calendar. We will be following up with you. And for the rest of you, we look forward to continuing our close work. Please, you know how to reach us now. We're there and really delighted to continue to build this relationship. Thank you all.
Thank you very much, Rebecca. Excellency, we know you are very short on time, so if I understand from your colleague that you might need to move to other meetings. If you have a bit more time, we'll just continue this closing speech with hearing from the executive director from SACRI, Mr. Kuda and Lou Kula. It's been very important for us to involve SACRI and to try to give a broader perspective of this training. It was primarily focused on Zambia, but also we were very happy to invite a few experts from other SADC countries and to also collaborate with SACRI, who is really the expert organization in the region. So Kuda.
I think I can listen to one more speech. I can listen to one more, not a problem. So we can carry on.
Perfect. Thank you very much. And Kuda, the floor is yours then.
Thank you, Arnold. Thank you, Honorable Minister. I appreciate your presence. Honorable Minister, Matthew Nkoa, Minister of Energy, Ms. Rebecca, again, Director for Africa, EU, Europe, and Middle East at IEA, Mr. Arnold Roget, Ms. Zaki Adam. A good morning to you all, and a good morning to the participants. I would like to thank first of all, start off by thanking the IEA for organizing this training for Zambia and extending the invitation to other SADC member states. I also like to thank the government of Zambia for hosting the training and allowing other SADC member states to join, which is a very clear testimony to the spirit of oneness in the SADC region. Again, to all the participants, thank you so much for joining, for your participation, because without you, then the training wouldn't have taken place. I would like to extend appreciation of the commitment of the Zambian government, especially the Minister of Energy, Honorable Methane, who has graced this occasion. Your great leadership and support, say, to the energy sector, and especially to SACRI, is greatly appreciated. I remember when you were appointed Minister of Energy, you immediately undertook upon yourself to sign the SACRI Intergovernmental Memorandum of Agreement, thus operationalizing SACRI. We greatly appreciate for the support that you are given to SACRI, say. Now, coming to the issue of the training and energy statistics, SACRI as a regional organization with a mandate to promote energy security and energy access in the region is very honored and very committed to see that efforts are being undertaken to capacitate the region in energy statistics and energy modeling. I would like to highlight the context of the SADC Renewable Energy and Energy Efficiency Strategy and Action Plan. In the RISAP, which is commonly called RISAP, it is highlighted that it is important to mention that updated statistics on energy access rates are missing in most countries. And this calls for further action for member states to conduct baseline studies, to conduct training, and then to update these figures. This will also capture the increasing role of, for example, microsystems, picosystems that are very critical in improving electrification access. There are challenges related to what is considered to be energy access, and member states need to agree on what definitions to use in order to compare performances with regard to the energy access goal. The role of biomass, as you have also heard in the past 25 days, is generally a guess estimate issue. So at SACRI, we have undertaken quite a number of projects which require a lot of data and statistics. These projects include the Energy Efficiency Program on lighting and appliances, ELA in short, the Green Hydrogen Potential Project, the Renewable Energy Decision Support Tools, the Renewable Energy and Energy Efficiency Status Report, the Distributed Renewable Energy for Productive Use with the Water Energy Food Nexus, within the Water Energy Food Nexus, also supporting member states with their national determined contributions. Amongst these, this requires definitely a lot of, as you can see, a lot of data. We've just concluded training on integrated resource planning, the RRP, which was highly appreciated by the countries. The training highlighted the need for data to model and build comprehensive, transparent, and informative power sector plan. A few countries have developed their RRPs and others are planning or in the process of doing so. We're glad to note that Zambia is one of the countries that have started also developing their RRP. Then comes the Integrated Energy Resource Plan, which will cover all energy sectors beyond electricity and is desired even more, and this is even more onerous in terms of data requirements. So we hope the training that has just been concluded by IEA will help the member states to establish and maintain energy databases and information systems as highlighted in RISAP. So in conclusion, this just highlights the importance of the training, and I appreciate IEA for responding to the regional desire and persistent requests for supporting in training for energy statistics. We hope to strengthen our collaboration, to formalize, strengthen our collaboration with the IEA so that the region can meet its developmental objectives. With that, I thank you.
Thank you very much, Kuda, for this overview of your activity in the region and for highlighting again the importance of energy statistics and planning, and also for mentioning our reinforced relation in the region. We are very much looking forward to collaborate more with SADC member countries. Okay, so I will thank everyone. Just reminding all our participants that this is just the first step of our collaboration, and more activities will come, including as soon as possible in-country activities in Lusaka, and much more to come, and we will share all the practical information very soon. And also, to close this course, we will kindly ask your feedback so that we can improve. So please share with us all your perception and feeling on this course. We will send very shortly diploma to all of you, and we very look forward to continuing discussing with all of you. Feel free to send any question, so that this relation that we initiated under this online course is a dialogue, and we are available to support and to answer any question you may have. With that, I'd like to thank you again, Honorable Minister, for your time and for your presence today. Thanks to you, Kuda, and also to you, Rebecca, Zakia, and all participants for having bred with us during all this online course.
Thank you, everyone.
Thank
Thank you very
so
much.
Thank you.
Have a lovely day.
You too. Thank you.
Thank you all. Bye-bye.
Thank you, Excellency.
Thank you. Thank you.
Honorable, good day.
Thank you. Good day. Bye.
Bye.
Bye. Bye.